This is the part 5 of the video series on properties of perfect squares or square numbers. The video links to the tutorials on part 1, part 2, part 3 and part 4 are given in the description box below. Please watch them first. Now, we have two tables here and each of the tables have two columns. In the first column, we have numbers and in the second column, we have their respective perfect squares. So the perfect square of 1 is 1, of 2 is 4, of 3 is 9, of 9 is 81, of 10 is 100. And same thing here. Okay, now if you look at these two numbers, that is 4 and 6, and if you look at these two numbers, 14 and 16, now this number ends with 4, this number ends with 6. They are single digit number, but they end with 4 or 6. This number ends with 4 and this number ends with 6. Now if you look at their perfect squares, this ends with 6, this ends with 6, this ends with 6, and this also ends with 6, right? Now look at another table, and if you look at 24 and 26, and at the units place, in this case you have 6, and at the units place in this perfect square also you have 6. That is, the number that either ends with 4 or 6 will have its perfect square ending with 6. You have 6 here, 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 you have 6 here. Now from these three tables, right, you can find that no other numbers perfect squares end with 6 except those numbers which end with either 4 or 6. Like here you have 1, you have 4, you have 9, you have 5, you have 9, you have 4, 1, 0, 1, 4, 9, 5, 9, 4, 1, 0, 1, 4, 9, 5, 9, 4, 1, 0. You can find the same trend for whatever number you take, right? So if your number ends with either 4 or 6, then their perfect squares will end with 6, right? So that makes actually sense. And why? Because let's say that your number is like 936 and times 936. So of course I'm not going to multiply these. So of course the first multiplication will be of this 6 and 6. So it automatically is you are going to get 6 here. And same thing is, let's suppose you have some 1, 2, 3, 4, 5 and you have 6 digit number, and let's say it ends with 4, and same thing is here, and it also ends with 4. So first time when you multiply with 4, you'll get, obviously you are going to get 6 only, right, at the last digit. So that's what you can see here. Now on the basis of this, if I ask you that, can you tell me the next 6 perfect squares ending with 6? So you'll say that that's very easy. First you have 4 and 6, 14 and 16, you have 24 and 26. So the next 6 will be like 34 times 34, 36 times 36, and 44 times 44, 46 times 46, 54 times 54, and 56 times 56, right? So 34 times 34, 36 times 36, this will end with 6, this will also end with 6. Then 44 times 44, this will end with 6. 46 times 46, this will also end with 6. I'm not going to calculate it, I'm leaving it for you. And then 54 times 54, this will end with 6. And then you have 56 times 56, this will also end with 6. So these are the next 6 perfect squares ending with 6. Okay, now suppose you are given any number, we don't know, a number, and that is a perfect square, and that ends with 6. This is given to you that it's a perfect square. Let's take an example, and it's an objective type question. So option A is a number ending with 3, option B is a number ending with 7, option C is a number ending with 4, and option D is a number ending with 6. Now if it's asked to you that of these 4 options, which is the number whose perfect square is this number. So instantly you have to reject this one and this one, because since this perfect square ends with 6, therefore there is no scope of those numbers which do not end with 4 or 6, right? So these two options get rejected. Now you have to check of these two, out of these two, right? So you can find out on the basis of that, and that will save your time and energy worked.